Welcome. This video talks about structs and arrays, using them together, and how they're similar and different. So arrays and structs are similar in that they're both ways to collect information, right? To take a bunch of things that otherwise would be individual variables and group them together so we can think of them as one unit and make it much more convenient for us, the programmer. The difference is an array is always homogeneous. It's always the same type. I can have an array of ints or an array of doubles, but I can't mix the two. A struct is usually heterogeneous. Sometimes we have a struct that's just two ints, but oftentimes it'll have some strings and some ints and some doubles and all kinds of different information we can mix together. All right, the struct, we have to access pieces by name. Give me student1.name or student1.grade. The array we access using the subscript operator. Give me values sub 1, values sub I. Other than that, they have a lot of things in common in terms of what we can do with them, right? So we can't do kind of bulk input or output to either one. We can't do comparison between two student objects or between two arrays in a meaningful way. We can't do arithmetic. I can't take two students and add them together. I can't take two arrays and add them together. But there are some things where they behave a little bit differently. A struct, I can use assignment to make a copy of, and I can't do that with an array. I can have a function that returns a struct. An array I can't do that with. The only way to get an array back from a function is really to pass in an array to the function and let that function modify the array. For passing, for an array, well, they pretty much always are passed like they were by reference. Right? We pass in an array, and the function is free to work with the original copy of the array. A struct, we can choose. If we don't specify by reference, we're going to get a copy of the struct. If we want to work with the original struct from the caller, we need to pass the struct by reference. Now, we can mix these two concepts. So I could do something like have an array of students. I could say, make me an array called students that is of type student, and I want 10 of them. And if I look at this in the debugger, I'd end up with something like this. And so I'm kind of relying on code from last time to do like the parse student example, to read in lines of a file called plainstudents.txt, so something that maybe looks like this, and turn it into student records. And so students would be an array. It would have 10 slots. Each slot would consist of a student. So if I want to go access, say, the name or the quiz of this first student, I'd have to say student 0, go do something. I can't access just the students sub 1. That doesn't make sense because that's talking about the whole student. I need to do something like, hey, go to students sub 1, go to the second student here, and change the name to Zorro. All right, but basically this part going into the array is going to give me one student, and from that student I want to get their name. Now if I'm calling a function and I want to talk about a whole student, then that's great. I could say print student and say the one I want to print is students sub I because I'm going through this loop, and so print this whole student. But if I want to talk about one particular part of one particular student, I have to go get the right student and then access that part. Now we can also have a struct that contains an array. So student might have a name, a birthday, and an array called scores, basically a list of 5 scores. Just like any other array, it's going to have a constant for the size. So this can't be based on a variable. So I've got this defined constant for how many scores there are. And a student might be initialized by something like this. There's the name part, there's the date part, and here's the array of scores. And so if I go access student 1, they'll have a birthday, a name, and this array of size 5 with the individual scores. To go access individual scores for the student, I could say go set student 1 scores. That'll get me to the array. Now set element 0, set that first score to 100. If I want to print out all the scores, I could print out the student's name and their birthday, etc., and then loop through all the scores. And so say with I from 0 to however many scores there are, access student 1, go to their scores, and get me this particular score. That's what I want to print out. In the sample files that I provide, you'll find versions of the student array that opens the plain students text file and reads in a bunch of students into an array and then prints them. And the complex students, complex students with array, so this is the one with test scores, and that just creates one particular student to work with. And then you'll find one more example. So this example works with this complex student.txt file. So this has got the name of a student, it's got the birth date, and then a list of test scores for that student. And so this final program is designed to take that those 30 student records and read them into structures so that we can do work with them. The basic data structures look something like this. We've got 10 scores, 30 students, 5 different grade levels at A, B, C, D, F that we're going to be worried about. So we've got some constants defining the sizes we're using. We have this struct that defines a student. And in main, kind of the first thing we're going to do is create an array of students with a size of 30. So 30 student records. We're going to pass that in to a function called readAllStudents. And that function takes in our array and the number of student records it's going to read. Since it's a constant, we could probably drop that parameter. But let's go actually look at the code for this. So this is the final example. .cpp is what it's called. And so down here at the bottom is our main. And I'm going to bounce up to that function. So like I said, we could probably omit the size since we know we're going to be working with a constant for the size. But it opens a file called complex students, and it goes through. We know we have to loop through whatever the size is, in this case 30. We're going to have to do that many things. And so we're going to have student index from 0 to 29. And to read in someone's name, so as we're working through this file to read in Maxine Q. Craft, what we need to do is say, oops, where's my final example? We need to go to the student list that we took as a parameter, our array of students. We know because this is an array, we're working with the original thing, so we don't need to worry about by reference. We'll take the current student, so current student number 0, and we'll read into their name. So we get one particular student, we access their name, and then the first part of their name, read that in, and then we'll read the middle and the last. And then we'll read in their birthday, because I know that's comes next, the birthday day, month, and year, just because that's the way it's set up in the file. And then we're ready to read in the test scores. And I know each student has num_scores scores, so we'll write a loop to do that. So we'll go get me the current student number, go to their list of scores, which is an array of ints. So within that array, I need to first read in 0, and then 1, and then 2, and then 3, and then 4. And so that's what J is doing for us. All right, the first array is all of our students. We go to a particular student to get their scores and read into a particular score. When this function's done, we return back, and this students array has been modified. And so then we can pass it off to print students records. And print students records, it's going to take in the array. It's constant because printing shouldn't modify the array, and so I want to protect ourselves from by accident messing anything up. And we'll print each student record. So print student record, we're going to call that function with each particular student. So we'll go to our array and get one student at a time and print them. So we can go look at that function. Here's print student record. It takes in one student, takes it by reference because we don't want to spend time making a copy, and it's constant because once again we don't want to mess it up. We don't want to make changes to it. It does some work to build up what we're going to print using a string stream, which if you didn't do the optional part a couple weeks ago, this is just a way to basically use a string like we would a file, to just send a bunch of stuff to it, build up a string that then we can print out. So I do that just to build up the name and print it out justified the way I want, and then print out all their scores by looping through this particular student. And because we're dealing with one student in this function, we can just say go to student S and get me their name and then the first part of it, or get me their list of scores and get me the ith score. But we're not talking in this function about a list of students. We're just passing one student at a time into that function using this loop. After that finishes, then we print out the averages for each assignment. And so I've got another function, get average for assignment, that takes in the list of students and the size and which assignment number we're dealing with. So we take in the whole array, the size of the array, and which assignment number, and we loop through for every student. We go get that student from the list, we get their scores, and we grab this particular assignment number, and we add their score to the total. And then once we're done, we can figure out the average and return that. Back to here where we can print out the average for that assignment. So I'm going to, at this point, just build and run the project, and you can see we suck in all the students, we print them out, and we print out last comma first and their scores. And then after we loop through and we've printed all the student records, we print their averages, we calculate and print their averages. So that's where the averages show up. And after we do that part, we return back to where we came from, which is main. And the last part is this print grade counts. And print grade counts goes through for each assignment and tallies up how many F's, D's, C's, B's, and A's we had. And we're not going to kind of walk through that code, but it's right here. We just create a two-dimensional array to store for each assignment. How many people got A, B, C, D, or F. We loop through each student in this calculate grade counts function and use that to fill up this array so that we can print out something like you see here. This example, this final example, it's a little bit more complex than you need to get for your last project. This print grade counts, you don't have to do anything quite that fancy, but this is your best example for the kind of work you should be doing for that last project in terms of making a big array of structures, reading them in, printing them out, things like that.